Hello, everyone. Good morning. Hope everyone is doing well. My name is Harsh Nayak, and I am a senior MySQL solution engineer working for Oracle. And today's topic for the webinar is what is new in MySQL 8.0.25. So in program agenda today, we have major 8.0 features that we'll talk about at the beginning. And then we will shift our attention to what is new in the latest release, which is 8.0.25. And then we will have some time to talk about the MySQL database service, which is the cloud offering of MySQL in Oracle Cloud, and its analytic engine, which is what we call it Heatwave. And then we'll provide some references of some of our customers who are using MySQL to run their critical workload, and then finally conclude this session with a separate Q&A session. So with this, let's kick it off with the first topic, which is the major 8.0 features until the latest quarterly release. Why MySQL 8? So MySQL 8 was the biggest advancement over its previous version, which was MySQL 5.7. It is twice faster than MySQL 5.7, and it comes with improved reliability and improved security. So we highly recommend our customers who are using MySQL 5.7 or lower versions, which are 5.6, 5.5, or even 5.1. It is highly recommended to upgrade it to MySQL 8 and then get the latest and greatest features and get full benefits of the latest version. And the word of caution here is please check the compatibility before you upgrade to make sure that the newer version will work well with your existing workload. The reason why we encourage all our customers to upgrade it to MySQL 8 is because MySQL 8 has all the right features, and here is a short selection. All the features, they range from performance to reliability to ease of use to security, so many developer-friendly features and enterprise-ready features. And because of all these things, it has considerable improvement over its previous versions, which are 5.7. So that's that's the main reason why we encourage all of our customers to upgrade it to MySQL 8. At MySQL, we have this continuous delivery model. So whatever new features are developed or bugs which are fixed, they're all released during this quarterly release. And if there is a major bug fix somewhere, then we are also releasing a new version outside of this quarterly release. So in the last quarter, we had some similar situation in which there was a major bug fix. And because of that, we had to make another release. So if you see, the latest release was supposed to be 8.0.24, which was released in April, 20th April, but then we also had this major bug fix, and because of that, we had to release, or we had to publish the 8.0.25 release. So if you're looking for all the details in what features were released in each version, then there's this URL at the bottom of the slide. You can click on it and can check all the features and everything. Here is the summary of all the, just give me a second. Here is the summary of all the features in the last 5 quarterly releases. So as I mentioned in the previous slide, the 8.0.25 is the bug fix, but as you can see, 8.0.24 basically has all the latest features, part of the latest release. And there are also some other releases that 8.0.22, 21, and 22, which were released last year, and 23 and 24, they were released this year. So I'm not going to go into the details of each and every quarterly release so far, but in the next upcoming slides, we'll talk about some of the features that we have released from 8.0 until the release of 8.0.24. So all those MySQL 8.0 features, they actually range from different attributes. For example, the transaction data dictionary all the way until the document store. And all these features, I have a few slides on each of them, some or multiple slides in some cases. So let's take a look at all of those slides. The first one is the transactional data dictionary. So in MySQL 8, all the metadata are stored in InnoDB tables. So there are no .frm or .opt or .par or .trm files, which used to be the case with MySQL 5.7. So with MySQL 5.7 or lower versions, all these things, they used to be stored in the file system, and they were relying on the MyISAP storage engine, which was the non-transactional storage engine. So with MySQL 8, everything is stored in the InnoDB tables, and they're part of the transaction, because InnoDB is the transactional data, transactional storage engine. All the metadata are part of the transactional data dictionary storage engine. The next is roles. Roles are collection of privileges. They can be granted like individual privileges, or they can also contain other roles. You can imagine roles as a convenient way of adding or removing and managing grants in your database. And I have my background in Oracle database development and administration, where I have used role as a very powerful security feature. So with MySQL 8, we have introduced roles in a very similar way. They work with the users. So the roles are basically, as you can see, they are stored in the user table. The names consist of the user and the host. The important distinction between the users and roles is you cannot log in as a role. And you can even provide a name and host when creating a role in the same way as you would when creating a user. And here is an example of creating the role. You can just use the very simple syntax, create role followed by the name of the role, or the name of the role, and at the rate the host. The next is window functions. So window functions are available beginning MySQL 8, which allows you to solve your query problems in newer and easier ways and with better performance. They gather the results into a set of rows and then return a single aggregated value for each of the rows in the result set. So unlike the group functions, which reduce the result set, window functions provide like the result for each and every row. So here is an example in which basically we have this table of sales and it has different years and different countries and different products. So if we are to provide the profit of, let's say, total profit in this case, and so here is the profit column, and if you're trying to use the window functions, so in this case, the first one is the total profit. So that basically encompasses the whole window, which is represented by this blue rectangle over here. So in this case, you just specify the window as over and then don't specify anything inside the parentheses. So that encompasses the whole window. And that basically gives you the whole profit here, which is like the profit for all the countries. But if you just want to specify the profit for single country, individual countries, then you can just do this over partition by country, and then you will get the result as like the here is the profit for Finland, here is the profit for India, and then finally the profit for USA. And so these are the windows represented in purple, yellow, and green. So this is basically how window functions work. The next is the common table expressions. They're also known as with queries. They're basically a named temporary result set that exists within the scope of a single statement, and that statement can be referred to later within the same statement. So as you can see, they're called with queries because they start with with, and the way you can define the common table expression is just in this case, we have CTE1 and then followed by the query, and then CTE2 again followed by another query, and then after you define them, you can use them in the later select statement as discussed earlier. The next big feature was the clone plugin. The clone plugin was introduced in MySQL 8.0.17, which permits cloning of data locally or from a remote MySQL server instance. The clone data is a physical snapshot of data stored in InnoDB that includes your schemas, your tables, table spaces, data dictionary, and metadata. So this clone data comprises a fully functional data directory, which permits using the clone plugin for MySQL Server provisioning. And the clone plugin was later used in one of the other features, which was released in 8.0.19. This is called InnoDB Replica Set. InnoDB Replica Set is a quick and easy way to get your MySQL replication up and running in short time. So the way it differs from the traditional replication is it automates a lot of tasks found in the traditional asynchronous replication, like configuring, adding and removing the members, and automating member provisioning using the clone method. It provided the manual failover capabilities in use cases that do not require the high availability offered by InnoDB cluster. So the main use case for the replica is scaling of the read operations. So a lot of the cases, you don't need the high availability, complete high availability, which is offered by InnoDB cluster. In that case, you can get this InnoDB replica set up and running in short time. The next feature is the replication from non-GDID source to GDID replica. So this feature enables the replication from a source server that does not have GDIDs enabled and does not use GDID-based replication to a replica that has GDIDs enabled. The use cases, there are a few use cases here. Basically, if you are running previous versions of MySQL and if you want to migrate it to the Oracle Cloud MySQL database service, then you can basically use this feature in which if you're coming from a different cloud or you're coming from a different on-prem environment, you can migrate it to the MySQL database service on Oracle Cloud. Or even you can check your existing production workload. If they have GDID mode off, then you can pre-check how it would behave if the GDIDs were to enable. The syntax is very simple. Just use change replication source to statement and then use the keyword assign GDIDs to anonymous transactions. The next is automatic connection failover for asynchronous replication. This new feature implements a mechanism in asynchronous replication that makes the receiver automatically try to reestablish an asynchronous replication connection to another sender. So in this case, if the current sender gets interrupted due to failure of the current sender, then the receiver automatically tries to reestablish the connection from another sender. So here is an example. In this case, there's this receiver, which is set for the asynchronous replication from sender 1. So now we have the sender list, which comprises of 3 senders, sender 1, 2, and 3. And as you can see, they have been assigned different weights. So in this case, the initial replication is between the sender 1 and the receiver. But sometimes, let's say if the network goes down or something wrong happened between the sender and the receiver and the link is broken, then what we can do with this feature is the next one in the sender list with the highest priority is sender 2 with the weight 80. So the link is automatically established between sender 2 and the receiver. And even sender 2 goes down for some reason, you still have sender 3 to fall back to. So the main use cases in this case, they are basically make deployments fault tolerant and improve the disaster recovery scenarios. Another important feature is the enabling and disabling of the redo log. So we started providing this feature of enabling and disabling of the redo log because this is very important when you're trying to load the initial data. So the use case here, when you're trying to load the initial data, you're already trying to load so much data, and all of them, they're going to go through this redo logs, adding the lots of information to the redo log, which you probably can avoid at one point when you're trying to load the data at the beginning stages. So what you can do is you can disable the redo log, you can load your data, and then you can enable the redo logging again. And the problem with this is if something goes down during the load process, then you have to do everything from the scratch. But the bright side is a lot of the times things are fine when loading the initial data. So if you disable the redo logging, then it can dramatically speed up your initial loading. And the syntax for this is very simple. All you have to do is alter instance and either enable or disable the InnoDB redo log. And this variable can be set at the global level. Word of caution, do not disable the redo logging on a production system because you're running your production and you need crash recovery, and redo logs contain all those data. The next is faster truncate or drop tablespace. So the drop table or tablespace process is basically divided into three segments. The first is InnoDB buffer pool adjustment. The next is cleanup of AHI, which is adaptive hash indexes. And the third is deletion of the file system. Now, the problem is the first two operations above, they cause the server to stall, and it gets worse with bigger buffer pool sizes. So if we have to understand this problem a little bit, let's see, this is our buffer pool, and this buffer pool is basically, let's say, sorry for my handwriting. So let's say it's anything greater than 32 gigabytes, okay? So in this case, if you're trying to execute this statement, drop table or tablespace, let's say they have some segments here in the buffer pool, some here, maybe some here. So what it does is it is trying to traverse through the buffer pool, and then it comes here and then say, okay, we need to remove this, and then we need to remove this, and then finally traverses here, we need to remove this, and then finish the traversing. Now imagine the problem with a bigger buffer pool size. So instead of like 32, imagine this is 100 gigabytes buffer pool, okay? So in this case, what happens is, and let's say the table that you're trying to drop or truncate is empty. So there's basically nothing related to this table in the buffer pool, but you still have to go through the entire traversal process all the way until the end, until the buffer pool is finished. So this is basically a problem. So until this traversal is finished, all the DML operations basically are stored. So the solution is we are trying to make this almost instantaneous, but how? So what we try to do is, instead of doing this traversal, we are completely not doing this part at all. So in this buffer pool, basically what we'll do is, let's say this is another buffer pool, smaller or bigger. Instead of like this traversal mode, if they have like pages over here, here, or here, buffer pool uses least recently used algorithm to evict pages. So when it is time based on the LRU algorithm that this page is not being used, then remove this page. And then if this is the page again not being used, this is the page not being used based on the LRU algorithm, then they will be removed. So this is how we will remove them lazily instead of instantaneously. The operations which are affected are drop tablespace or drop table or truncate table, or in some cases, implicit temporary tablespace truncation as well. And we have seen results up to 251 times faster. The next is read-only schemas. This feature provides a mechanism to prohibit writes to your entire schema. It is only allowed with alter schema. It's not compatible with the create schema. So you cannot create the schema and then put it in the read-only. You have to actually alter to make it read-only. The purpose of this feature, the use case as we call it, is the support for migration. And so suppose you have like 10 schemas with a single MySQL instance, and one of the schemas goes 10 times large while the others stay relatively the same. So in this case, it might be relevant to do an online migration to move the schema from one instance to another. And the migration will involve a logical dump or restore and then catch up using the binary logs. Now, while the migration is occurring, the source schema is accessible for writes, but there's a point in time when all writes to the source schema must be stopped and all read-write traffic must be switched to the new service. So at this point, a mechanism is needed to fence the original source schema and prevent any writes from getting through. Otherwise, once the switchover happens, any additional writes are going to be lost. So this is where the read-only schemas are very useful. It's very simple. Just do alter database and then read-only equal to 1. The next feature is invisible columns. As the name suggests, that they are basically hidden to the queries. So how can you access them? Well, they can be accessed by naming the column explicitly. So let's see how it works basically. This is the table in which we have created this column 2 as an invisible column. So if you're trying to insert any values, you have to provide the explicit name of the column. And if you're trying to select everything, so as we see that the column is invisible, so in this select star from T1, it will not produce the result for column 2. But if you want to access it anyway, then you have to specify the name here. And then this is the way basically it will be accessed using the explicit reference. What is the use case here? Again, the application migration. So suppose your application database has table with 2 columns, and for a newer version of the application, the new columns are added to the table. But to make the old application work as before without any changes, the new columns are marked as invisible columns. So the new version of the application uses columns by explicitly referring to them in the query. The next feature is the error log. So of the logs of MySQL Server maintains, one is the error log to which it writes diagnostic messages. Now for general and slow query logs, as you can see, we already have the option to write the contents to a table. But for error log, typically the server writes these diagnostics to a file on the server host or to a system log service. So as you can see, for general log, we already have the table. So you can also write it to the file, but in case of error log, it was only available to the operating system. So now we have created another table called error log, which is part of the performance schema. And the way you can query this table is basically just very simple. Select star from performance schema.error log, and it gives you all the diagnostic information that is stored in the error log table. And this gives the freedom to DBA to not have the access to the operating system, because instead of accessing this, you can just query this table and not access the operating system file. Then a few changes that we have made in MySQL Shell. There are 3 new methods that we have introduced: dump instance, dump schemas, and load dump. Dump instance, as its name suggests, it dumps the entire instance, and dump schema, it basically exports a schema or a bunch of schemas. And load dump, whatever was dumped using the dump instance or dump schemas, they're basically loaded using this load dump method. Now, why they are very important? It's because they're a considerable improvement over its traditional tools like MySQL dump or MySQL pump, because they are multi-threaded, has great speed for export and import, 3 GB for export, 200 for import. It does the loading in parallel. You can also do the export and import parallelly in concurrent way. And you can also abort and resume the load, because it has the progress file, so it tracks the progress, and you can resume from the point where you left off. It also compresses your data, so you can save save on storage while exporting the data. And it is very important when you're trying to migrate it to, let's say, Oracle Cloud, in which you can initially just dump all the data to the OCI object storage, and then using the MySQL database service, you can directly import it from the load dump utility. Here are some of the benchmarks that we have done, which are comparing this MySQL Shell utilities to the traditional tools like MySQL dump or pump. And there's also a tool called MyDumper. So as you can see, this pink bar, it outperforms in most of the cases, except for the Wikipedia database, which has different characteristics. But we have the improvements coming to make this utility better in the upcoming version as well. And the load utility, as you can see, it outperforms all the traditional tools, including the third-party tools for loading the data. So as you can see, there's considerable amount of performance improvement when you're using MySQL Shell for loading your data. The next is router, which basically in the old limit for routers to for the maximum number of connections that you can have is 5,000. So beginning MySQL 8.022, the new limit is up to 50,000 connections. The maximum, of course, depends on the operating system's limitation, as well as the number of CPU cores per threads. And if both of them support, then you can achieve up to 50,000 connections using MySQL router. And then finally, the major big change was in 8.0 was the document store, which is basically the NoSQL documents, it's schema-less JSON documents. So you already have your relational tables, and then now you can also host your JSON documents in the same database. They basically are stored in the InnoDB, which is again the transactional storage engine, and provides full ACID compliance. And it also provides multi-document transactional support because everything is stored in the InnoDB. So at this point, you basically don't need to go to another database for storing your NoSQL data. You can use the same database. So it's a reduced effort and it saves cost. Now, so much we have talked about 8.0 features. Now let's focus our attention on the latest release, which is 8.025. So what is new in 8.025? We will talk about some of the features across Optimizer, GIS, which is Geographical Information System, InnoDB, Replication, some group replication feature, and the routers. The first one is transform correlated subqueries. So before we get into this feature, what is a correlated subquery? So the correlated subquery is a subquery that uses values from the outer query. And because the subquery may be evaluated once for each row processed by the outer query, it can be slow. And that's how the traditional implementation of correlated subqueries in any database. So what this feature does is it implements the transformation of a correlated subquery into a derived table. Now, why do we need this? Simply for improvement. The transformation avoids materializing the inner subquery several times, and the derived table is synthesized from the subquery and is grouped on the column presented in the correlated predicate. So if we have to see the example, here is the correlated subquery. So there's this table T1, and we are trying to use the value from T1 and trying to access something from T2. So this is why this is correlated query, because the outer query is actually used inside the inner query. And then the way correlated subquery works is everything for fetching the data into T1, all those for all those rows, this query, the inner query, will be executed once for everything that is fetched in T1. So that's going to be a slow process. So what we are doing is we are trying to transform this subquery into this derived table using this join. So this particular subquery is now converted into this join, which is derived table. So in this one, instead of like executing this multiple once for each row process, basically we have converted this into a derived table, and that will not be executed every time for this outer query. The next is some improvements in GIS, Geographical Information System. The first improvement is the explicit cast between the geometry types. So this new capability is added to use explicit cast to convert geometries into other compatible types. For example, multipoint to line string or line string to multipoint. And these are just two examples. But if you are interested in like finding out all the comprehensive list, then you can go and check out this feature in the documentation of MySQL. And we have listed all the things that you can do using the explicit cast. Another new function that we have added is st pointed distance, which accepts two arguments, line string and distance in range, and it returns a point along the line string at the distance from its start point. So imagine here is your line string, and you're trying to get a point at a distance, let's say 400 meters. Okay, so this is 400 and this is 0. So the use case is it suggests which point value is 400 meters from the start of the road. So in this case, if you're trying to get this point at 400 meters, you will use this function point at distance and you will get this point right here. Another new function which was added is StCollect, which aggregates geometry values and returns a single geometry collection value. Here is an example. Let's say you have this table product in which you have this location geometry, and we have added a bunch of values and used the point geometry for the geometrical data. And if we are trying to, let's say, use this StCollect function, and so we are trying to do the collection based on this location object, location column. So the result would be a multi-point, which is basically the aggregate of all these points. So as you can see, all the 6 points are listed over here. But if you are trying to do the distinct location, that means you only want not all the duplicate points. Then as you can see, this one is duplicate, or 60 is 24 is duplicate, and this one is also duplicate. So in the distinct aggregate, you will only get the unique values. The next is two more functions, which is StLineInterpolate point and StLineInterpolate points. The difference between two functions is this S over here. So both the functions, they accept the similar arguments, line string and fractional distance, and they return a point, or in this case, multiple points along the line string at the given fractional distance, which is another argument which is accepted in both the functions. And they give you the point or points alongside that line string on this fractional distance. So the use case would be, let's say here we have this geometric line string, which has like, in this case, let's see, this is 0 and this is, let's say 5. And this is 5. So this is my x-axis, this is my y-axis. And if you're trying to interpolate a point at a fraction of 0.5 distance, then you will get 0.5. So you'll get a point somewhere right here. And if you're trying to interpolate a point at a distance of 0.75, then you will get it somewhere over here, which is 2.5 and 5. And in this case, let's say if you're trying to do instead of point, multiple points, so interpolate multiple points at the fraction of 0.25 or 25% along the way, then you get like multiple points as like 0 and 2.5, and the next is 0 and 5, the next is 2.5 and 5, and then finally 5 and 5. So this is how both the functions work in interpolating points. The next is configuration to control clone donor timeout after the network failure. So we visited this clone plugin earlier in this presentation. So during the clone, if there is a short network outage between the donor and the recipient server, the donor waits for network to restore and recipient to connect and resume cloning. And the donor wait time currently is fixed at 5 minutes. So before MySQL 8.0.24, let's say if for whatever reason, the link between the donor and the recipient is broken, the minimum time is 5 minutes. But let's say in some cases, the network restore takes more than 5 minutes, or it could be like 10 minutes, 15 minutes. So, and imagine you're transferring like almost 100 terabytes of data. So this is your donor and you're trying to transfer 100 terabytes of data here. So this basically all the operation that you have done, let's say you break at 90 terabytes, then you will have to restart everything. And which is kind of like maybe if the network was restored in 10 minutes, then, you know, just for the another 5 minutes, you'll have to do this whole operation of copying the data and cloning the data. So in order to avoid this, what we have done is we have introduced this new variable, which is clone donor timeout after network failure. We have kept the default at 5 minutes, but now you can configure it anywhere between 0 and 30 minutes. So if it is configured, let's say in any of this time range, then instead of like restarting this operation, it will resolve it automatically and it will continue from that point on. Pros, well, it allows more time for resolving network issues and avoids copying multiple terabytes of data. But it also has some cons because it increases the size of the delta on the donor instance, because until this network outage is restored, the donor has to keep up with the delta. And it also increases the clone recovery time as well as the replication lag, because until the donor is, the recipient is caught up, it is basically behind the donor. The next is TLS support in MySQL Server mock. So MySQL Server mock is basically a dummy MySQL Server for testing MySQL router. The current setup, it says that you can set up the dummy MySQL server with the right certificates and configuration, and then start the MySQL server, test out the application, and then stop the server, and then rinse and repeat the same procedure. So with this new feature, what we have done is we are allowing it to enable TLS certificate or TLS support with proper ciphers, appropriate certificate, X509 certificate. And so the full TLS support basically that comes with the certificate and authentication, everything is allowed using this MySQL Server mock. The next is for the router, accept connections only if the destinations are available. So the current behavior is that when the router is opened, its listening sockets when it starts, and they're kept open until the router shuts down. Now, the problem with this is it could be misleading for external applications that may assume that they can forward the traffic even though the router do not have any destinations on its part. So to avoid this listening, the sockets must be shut down if there are no valid destinations, and new connections must not be accepted if there are no valid destinations. So the new behavior is only bind to the sockets if destinations are available and close any incoming socket if no destinations are available. The next is change default X protocol port. So there is this variable called conf base port variable, which defines the base value used for the listening TCP ports by setting bind port for each bootstrap route. So this value is basically used for classic read-write route, and then also for the X protocol read-write. So as you can see, the classic read-write is 6446 for the router and 6447, and for X protocol is 64460 and 64470. Now the change that we have made is in this part. These are the new values that we're introducing. Now, why did we make this change? It's because these are the old ports or something called dynamic port range, which are defined by IETF. Now, the dynamic port range is basically this range, 49,152 to 65,535. So as you can see, both of these values, they fall in this particular dynamic port range. So if you are having a high connection system, then these ports might be already in use when the router is trying to bind the new connections to these ports. So instead, basically there are user ports which range from 1024 to 49,151, and they're all unassigned. So basically, instead of using the dynamic port, which you might risk hitting into used ports, instead, you can use these unassigned values and use the 6448 and 6449 to be on the safer side. The next, make skip slave start a global, persistable, and read-only variable. So the skip slave start is basically an existing variable that tells the replica server not to start the replication, IO, and SQL threads when the server starts. And to start the threads later, you need to use start replica or slave statement. So the old behavior is It at the moment, only operating system privileged users may add skip slave start to the to control it as a parameter at the server bootstrap. And the new behavior with version 8 or 24 or 25, you can use the skip slave start system variable in place of the command line option to allow access to this feature using MySQL server's privilege structure rather than the operating system privilege. So in this case, the database administrator does not need the privileged access to the operating system. As I mentioned, the motivation for this is DBS don't need to have any access to the operating system. The next is make IP allow list modifiable while group replication is running. So group replication IP allow list is a variable which basically specifies which host can connect to the group. The current behavior is you can't change it while the group replication is running. You have to stop it, you have to change the allow list, and then you have to start the group replication. The new behavior is it can change the allow list while the group replication is running. What is the motivation? Well, just to lift the limitation instead of like having to go through the start stop procedure. You don't need to do anything. Just change it dynamically while the group replication is running. And now, so much we have talked about what we have done in 8.0 and what we have released in the latest quarterly release. Now, let's talk for some time about our new cloud offering, which is the MySQL database service in Oracle Cloud and its analytic engine, which we call it Heatlh. So MySQL database service is very easy, secure, and enterprise-ready cloud offering in Oracle Cloud. It's easy because it's fully managed service, automating all your time-consuming tasks such as patching, upgrades, backup. You can instantly provision to get applications into production faster. Comes with all the latest features to deliver modern and cloud-native database applications. It is secure because it comes with the data protection with encryption, masking, auditing, and many more secure features. Comes with advanced security to help you meet your regulatory compliance requirements. And you get the latest security updates to limit your exposure to security vulnerabilities. And it's enterprise ready because it's built on the MySQL Enterprise Edition. So here's the difference between the MySQL cloud offering in Oracle Cloud versus in other clouds. So in other clouds, most of them, they are providing either the community version or the forked version of MySQL. Only in Oracle Cloud, you get the enterprise edition of MySQL, which is also compatible with your on-premise MySQL deployments. And that's built on the Gen 2 cloud infrastructure, which offers the core-to-edge security for performance workloads. The next is, as you can see, most of the features in the MySQL database service, they are completely managed. So everything that you have to do traditionally for database management or operating system management or for server or storage or data center, as you can see, all the tasks are completely automated. And the price is very competitive as if you compare it to the major competitors in the cloud. So as you can see, the annual cost for running 100 OCPUs and 1 terabyte of storage in Amazon and Microsoft Azure, it costs more than 200,000, and Google, it costs like 170,000. But as you can see in Oracle MySQL database service, it's very competitive price, only 65,000 for annual cost. Now with this, we have also introduced another engine, which is called Heatlh Engine, which basically runs the analytics. Here is the comments from our chairman and the CTO, Larry Ellison, about the Heatlh. Basically, the most interesting of this new OCI managed service is for the popular open source database MySQL, and MySQL plus Heatlh processes queries hundreds of times faster. The amazing thing about Heatlh is that you don't have to move your data out of MySQL. And basically the good thing about Heatlh, as mentioned here, is you don't need to move your database anywhere else. Everything that's running in MySQL is going to run in Heatlh without changing any syntax or any procedures. So why did we actually introduce Heatlh? It's because analytics on MySQL data has always been the problem. So MySQL has been the #1 open source database, but there is not a simple solution to run analytics. So as you can see, MySQL is basically mainly optimized for the transaction processing workload. But if you need to run analytics, basically, you're trying to run it outside of MySQL in most of the cases. And that actually leads to the ETL process, and you end up with two databases, and basically you can't support them in real-time analytics. So in order to deal with all these problems, now with the Heatlh, what we have done is we have provided this in-memory analytics in which all the changes that you make to your InnoDB, they're basically changed, they're propagated to in-memory analytics in real time. So the advantage is you can continue connecting your OLTP applications to the MySQL database service. So this you can think of as the MySQL platform that serves both your transaction processing and analytics needs. So on this side, you can connect your OLTP, and on this side, all your new analytics, instead of connecting it to somewhere else, now can connect to the same platform, and OLTP will be served using this InnoDB, and all your analytics, they'll be served using this in-memory analytics. And as we have done some performance benchmarks, as you can see, the queries are 400 times faster on a TPCH benchmark with 400 gigabytes of data and 64 cores. We compared it to MySQL InnoDB, and as you can see, it's the 1700 second versus 4.21 seconds. So that's a ridiculous amount of improvement. If you're interested in letting the MySQL experts improve the performance of your slow queries, then you can sign up on mysql.com/healthcheck and go for a check out the performance health check for your database. Now, we will provide some references. So as you can see, MySQL boasts an impressive list of customer base. It covers a broad spectrum of the industry, including social media, telecom, finance, manufacturing, etc. And these customers use MySQL to run their mission-critical workloads. If you're interested in checking out the MySQL database service that we just visited a little earlier, then you can do it in Oracle Cloud by going to the URL below, and you can get $300 in the free credit, which is good for 30 days, and check this service out. And if you want to stay in touch with us on the social media, there are social media handles for Twitter, MySQL, twitter.com/MySQL, Facebook, LinkedIn. You can subscribe to these updates, and all the new features all the new releases that we are doing, you'll be able to find all the relevant news in there.